This video will be going over the process of building your electric vehicle champion kit. The list of materials and access to all other guides and helpful diagrams can be found on our website under the kit instructions page, which is linked in the description below. The first step is to attach the 5mm shaft coupler to the gearbox. When completing this step, it is important to align the shaft coupler's set screw hole with the hole on the gearbox's shaft. After they are aligned, you can then tighten the set screw onto the gearbox shaft. The next step is to attach the motor to the gearbox. This gearbox is compatible with most 550 size motors, and these motors can be mounted using two M3 bolts. After attaching the motor to the gearbox, we can then attach the spur gear to the motor shaft. This spur gear is typically included as a package with the gearbox, but in case you are missing it, the specs are on screen here. With the spur gear attached, we can adjust the position of the motor so that the spur gear meshes with the gearbox. During this process, it is important to ensure that the connection between them is not too tight. This next step is pretty straightforward. We're just going to be attaching the gearbox to our back axle 3D printed part using four 12mm long or 1/2 inch long M3 bolts. Now we're going to use a very small amount of super glue and attach two bearings to the two bearing slots on our back axle piece. This next step involves cutting carbon fiber. Now the best method to do this is with a Dremel or a bandsaw. However, because we are making very simple cuts on not very large or thick pieces of carbon fiber, it's very possible to use a basic hacksaw, which is what you can see me doing here on screen right now. For this step, we need to have two pieces cut from our 5mm diameter carbon fiber rod. We need one piece that's 5 centimeters long and another piece that's 4.5 centimeters long. Now we can lightly sand these pieces using any type of sandpaper you have on hand. Here I'm just using 120 grit. But we're going to sand these pieces until they're able to slide through those ball bearings relatively easily. Next, we can attach the carbon fiber rods to the shaft couplers in a more permanent fashion using some super glue, and here I'm going to place a little bit into where those set screws screw into. Now this helps prevent any slippage of these rods over time and with testing. Afterwards, we can attach our T61 hubs to the ends of our carbon fiber rods. And now we can attach our bearings to the front axle piece. This is the exact same process as attaching them to the back axle piece. Now we can cut a 12.5 centimeter long piece from the 5mm diameter carbon fiber rod for our front axle and sand it down until it is able to slide through the bearings. Alright, so the next step here is to finish assembling the front axle. So the first thing we're going to do is we are going to attach our encoder to the encoder slot on the front axle piece using three 12mm long M3 bolts. Now we can attach our 6mm bore belt pulley to our encoder shaft. Alright, so now we can attach our front axle to the bearings, and after sliding the front axle piece through one bearing, we can then slide on our 5mm bore belt pulley and our timing belt onto both pulleys, and then finish pushing the carbon fiber rod all the way through the both bearings, and making sure that we have at least 1.5 centimeters of extra carbon fiber sticking out on both sides. We can use some super glue to secure that carbon fiber rod in place. And finally, we can attach our remaining two T61 hubs to our front axle. The next step is to cut the end off of a metal caliper. The best way to accomplish this is with a bandsaw, however it is possible to do this with a hacksaw and a lot of patience. When cutting the caliper, you want to remove the depth gauge and cut the ruler portion to roughly the 110 to 120 millimeter mark. You can also remove the little dial wheel as well to give yourself a little bit more room to adjust that caliper. This is what your caliper should look like when you're done cutting it. The next step here is to cut our carbon fiber for our chassis, and we need to cut 3 55 centimeter long pieces of our 6 millimeter long carbon fiber tube for our chassis. To make sure your vehicle fits within the 70 centimeter wheel length limit, while also ensuring that all other electronics fit on the chassis, it's important to ensure that the rods are between 50 to 55 centimeters long. Now we can assemble the caliper module by attaching the caliper to our caliper attachment 3D parts. When completing the step, it's helpful to use some of these scrap 6mm carbon fiber tubes to make sure that the 3D printed pieces are properly aligned. After having everything aligned, we can then use a decent amount of epoxy to secure the caliper to the 3D parts. Please let the epoxy set before attaching it to the chassis. Now we can use some super glue to attach the 6mm carbon fiber tubes we previously cut for the chassis onto the back axle piece. Now we can slide on all of our 3D parts onto the chassis in the order you see on screen here. So we have the BTS 7960 motor driver holder, then we have the mount for the Arduino Uno, and then we have the LCD screen mount, and then the mounting piece for the scope, and then the caliper piece we made earlier, and then we have the front axle piece. Now we can attach our front axle to the front axle mount using a 16mm long M3 bolt, an M3 nut, and a lock washer, which is unfortunately not shown in this clip. You want to push the M3 bolts from underneath the mounting piece up through the front axle piece, and then you would want to tighten an M3 nut onto the bolt with a lock washer in between the M3 nut and the 3D piece itself. The lock washer helps prevent unintentional pivoting of the front axle outside of moving or adjusting the caliper. Now we're going to cut a piece of the 3mm long carbon fiber tube to make an arm that links the front axle to the caliper. To determine the length of the carbon fiber, you should first place the caliper arm into about the middle position that you can get it to. Then you want to measure the point-to-point distance of that mounting hole on the adjustable caliper arm to the mounting hole on the front axle piece, then subtract 1 centimeter. For me, that length was 11 centimeters, so I cut a 10 centimeter long piece of carbon fiber, of that 3mm carbon fiber tube. Then you can simply glue in the caliper arm heads onto that 3mm long carbon fiber tube. Then, using a 12mm long M3 bolt, a 20mm long M3 bolt, 2 M3 hex nuts, and 2 M3 lock washers, we can attach the adjustment arm to the caliper and to the front axle. Again, lock washers are unfortunately not shown here, but they're very helpful in ensuring tight connections between the caliper arm and the respective attachment points. Alright, so now we are going to attach the electronics to our chassis, and when doing so we'll be using a lot of 1/4 inch long number 6 screws. First, we can attach our Arduino Uno mount to the chassis, and when doing this you want to make sure that the 2 square slots are oriented to the left side of the vehicle. Then we can attach the Arduino Uno to the Arduino Uno mount. And now we can attach the Arduino Uno shield included in our PCB set sold on our website to the Arduino Uno, and then we can attach the BTS7960 motor driver to the motor driver mount. And now we can attach the buttons piece from our PCB set and the LCD screen to the LCD mounting 3D printed part. Alright, so now we are going to be connecting the motor to the motor driver. And then depending on the motor you are using, you may not need to add any additional wire. But for me, my motor isn't able to reach the terminals on the motor driver. So what I'm going to do here is I'm going to cut the ends off of that motor and then strip the wire, and then use a simple lever connector to connect each end of the motor wire to some extra 12 gauge wire. Then we can use that wire to connect the motor to the motor driver. With this extra wire added, we can now connect the motor to the motor driver. The 2 terminals on the left correspond to the motor output, and the 2 on the right are for the power input. You can verify that these are the proper terminals on your motor driver by checking the labels on the underside of the motor driver. Now we can use some 10 cm long female to female jumper wires to connect the motor driver, the buttons, and the LCD to the Arduino via the Arduino motor shield. Please note that the Arduino PCB has been updated since the recording of this video. However, the only cosmetic change you'll notice is the position of the terminals for the encoder wires. The wiring you see on screen right here is the exact same with this new Arduino Uno PCB that is included on our website. To give a little bit more clarity, I want to run through the pins and how you can determine which ones need to connect where. And on both the Arduino Uno PCB and on the electronics themselves, there are labels corresponding to each pin. Now, the buttons PCB and the LCD PCB are a lot more simple. You can see each pin is individually labeled. So you have a set pin, which corresponds to the set pin on the Arduino Uno, and of course the set pin on the button set. You have a ground, VCC, SCA, and SCL on the LCD, which corresponds to the SCL, SCA, VCC, and ground pins on the Arduino Uno mount. The only one where it gets a little bit tricky is with the motor driver. However, there is a corresponding grid right next to it that tells you the layout of the pins. So you can see here on the Arduino Uno mount, there is the box on the all the way to the right, and at the bottom is labeled VCC. Now that means that the pin all the way to the right and at the bottom is the VCC pin. And this is the same thing you can see on the motor driver. You can see that there is a VCC pin on the top top left, so that would mean that the top left pin is the VCC pin, and so on and so forth. So now we can go ahead and connect the encoder to the Arduino. But first we need to do some quick cable management. So what you can see me doing here is I'm giving myself a little bit of slack of the encoder wire, at the very front, so that we're able to still pivot that front axle with the caliper. But then what I'm going to do is I'm going to do a little bit of just a few wraps of that wire around the leftmost carbon fiber tube, and then I'm going to thread that wire underneath the caliper and then underneath where that LCD sits, and then rescrew back in that LCD. Now, rescrewing back in that LCD acts as a little bit of a clamp of that wire to help make sure it doesn't move during testing or unintentionally. After you reattach that LCD, you can go ahead and cut off some excess wire. I'd like to leave at least 3 to 4 inches of extra wire just in case you mess up stripping the first time. You don't have to buy a whole new encoder. Now we can go ahead and strip the wire and then attach the wires to the encoder terminals on our Arduino Uno PCB. The black wire is the ground wire. The red wire is the VCC wire, the green wire is the encoder A wire, and the white wire is the encoder B wire. If any of the wires are not the same colors that I've mentioned here, you should at least have a black wire corresponding to ground and a red wire corresponding to VCC. The encoder A and the encoder B wires are the other 2 wires, and you can connect them to whichever one you like, and then you can troubleshoot which one is actually the encoder A and encoder B wires, which we'll discuss in the calibration video. Now we're going to complete our battery wiring and then quickly make some attachment or mechanism so that we can quickly remove and reattach our battery holder. So what we're first going to do is we're going to attach some Velcro to the underside of our 8AA battery holder, and then attach the opposite side of Velcro of the same length into that little 8AA battery holder on the back axle piece. From then, we are going to use 2 3-way lever connectors to connect the terminal wires that attach the battery pack, a right angle power wire for the Arduino Uno, and some 12-gauge wire to connect to the motor driver. This is a better image of what that wiring actually looks like. So you can see we have the ground wire of our battery terminal connector. We have the ground wire that connects to the motor driver, and then we have the ground wire for the power cable for the Arduino Uno. And similarly, we have the power wire for the battery, the power wire for the motor driver, and the power wire for the Arduino Uno, all connected to one of the 3-way lever connectors. In terms of connecting the wires to the motor driver, the positive wire from this connection connects to the terminal directly adjacent to the red motor wire, and then the black wire, the ground wire for this power connection, attaches to the terminal furthest to the right on the motor driver. Now we can attach the wheels to the wheel hubs using the snap rings included with the wheel hubs and some snap ring pliers. Now we can make a measuring point and attach it to the front axle. For this measuring point, we need to cut a 2.5 centimeter long piece of the 3mm carbon fiber tube, and then insert that into the slot on the front axle mounting piece. When gluing it, please make sure that the bottom of the measuring point is less than 1 centimeter from the floor. Now to build the scope attachment, the first thing we need to do is we need to get 4 disc magnets and glue 2 into the motor holder and 2 onto the motor mount on the chassis. When doing so, you want to make sure that the polarities are aligned so that when you go to try to attach the motor holder onto the chassis mount, that they actually stick together. Now we can go ahead and attach the scope to the scope holder 3D printed pieces by sandwiching the scope in between the top and bottom pieces. So what we can do now is, after placing those pieces over the scope, we can use 4 20mm long M3 bolts and tighten them, tighten the top piece to the bottom piece. Now there are no nuts in that bottom piece, but the size of the hole is small enough to where you can pretty much press these or screw these bolts directly into them. Now you can see that I have placed my scope in the scope holder, near the back end of that scope. But you can really place the scope anywhere you'd like. You can even remove that central hub of the scope and adjust as you need it, or whichever makes aiming easier for you. With that, your electric vehicle has been successfully built. Please check out our other videos about the code and how to calibrate your electric vehicle. With that, thank you for watching and stay unfazed.